Just made it on that last one. So we left off on the last problem, in the last video, problem 45a. We found the equation of the tangent line. 45b, all we need is the equation of the normal line, and we know that the slope of the normal would be the negative reciprocal of the slope of the tangent, and we found that the slope of the tangent line was 2 over radical 3. So the slope of the normal line then would be negative radical 3 over 2, and therefore we can go right to the equation of the normal line. That's y minus y1 equals the slope. Now again, this is the slope of the normal line, negative radical 3 over 2, and then we multiply that by x minus 3. And that's the equation of the normal line. Okay, onward to number 46. 46, we've got trig. Always poses problems. Again, we need the derivative, so derivative is negative cosecant squared of x minus 2 times. Now, the derivative of cosecant of x is negative cosecant cotangent. Negative cosecant of x, cotangent of x. And then we need to figure out what's the slope. So if you're trying to remember or try to understand, if you're trying to understand what the process is here, then just watch and listen to my explanation for what we're trying to do here, finding the equation of a tangent line. Just listen to the explanation for problem 45. I'm just going to do problem 46 with the understanding that when we want to find the equation of a line, we have to come up with the slope and the point, and we are going to use derivatives to find the slope, and then we're going to use algebra to find the y coordinate of the point. So nevertheless, what we need here is the derivative at pi over 2, because the derivative at pi over 2 is the slope. Okay? And so we're just going to plug in the pi over 2, negative cosecant of pi over 2, and we're going to square that. That's what that means, negative cosecant squared, minus 2 times. Now, if I look over here, I can save myself a little bit of trouble. Notice I've got a minus here, minus 2 times a negative term. And so negative, negative, that's going to give me a positive. So I'm just going to make that positive. Okay, and I'm going to write it as cosecant of pi over 2. I can already see that cotangent of pi over 2, meaning cosine over sine, that's going to be 0. So I already know that. That's equaling 0. That makes that whole second term 0. That's kind of nice. And then we have negative. Now, cosecant of pi over 2, cosecant being 1 over sine. Sine is 1, so 1 over 1 would be 1. And negative 1 squared. Don't make the mistake of squaring the negative 1. You're not squaring a negative 1, you're squaring a 1. Okay, so you have to do this first. Exponents come before multiplication. So negative 1 squared, which is negative 1. So there's our slope. All right. Well, if that's the slope, well, we need a y1, don't we? We have y equals 4. Let me do this. Y, when x is equal to pi over 2, would be equal to 4. So this is finding our y. So we have our slope is negative 1. If we look over here, negative 1 is our slope. We need a y value at the point when x is equal to pi over 2. So y at pi over 2 would be 4 plus cotangent of pi over 2, which we already know is 0, minus 2 times the cosecant of pi over 2. And again, the cosecant of pi over 2 is 1. The cotangent of pi over 2 is 0. So what we end up getting here is y at pi over 2 is 4 plus 0 minus 2 times 1, which is 4 minus 2, so we get 2. So that value right there is the value that, is our y coordinate when the x coordinate is 2. So we have everything we need. We have our slope, we have our y coordinate, we have our y coordinate, which is 2, so y minus the y1 equals the slope, which is negative 1, times x minus the x coordinate, which is pi over 2. And so that guy is our equation of our tangent line. And we can go right into the equation of the normal line, and again, the normal line is through the same point. The slope, if -1 is the slope of the tangent line, then the negative reciprocal of that would be +1 multiplied by x minus pi over 2. So that was an easy one as far as the finding the slope of the normal. Slope of the tangent is -1, slope of the normal is +1. So that's number 46A and B. 47A and B. I like these problems. These are the more, I guess you could say, the more realistic problems that you'll see in AP Calc, where you actually have to use a derivative to find something else, and so that's important to be able to do that. For number 47, we have a curve, and it actually gives us both an x and a y. Here we see, you should recognize that this curve is the curve of an ellipse, and I won't graph the ellipse, but nevertheless, you need both an x and a y to figure out where that tangent line is going to hit, because the tangent line, where it is, depends not just on x, but it also depends on y. So what we're going to do here is we're going to use the process of the implicit differentiation to come up with our slope. So now, really, if you think about this, the only thing we need to find is the slope, because we already have our x1 and we have our y1. So you've done this a million times, finding the derivative, and then you just have to plug in the x and the y, and you get the slope. So if you need more help on the implicit, then go back to the implicit lesson. But nevertheless, the derivative of x squared with respect to x is 2x, plus the derivative of 2y squared with respect to x is 2 times 2 is 4, y, and then we multiply that by y prime because we're taking the derivative of that term with respect to x. Okay, and we know that the derivative of 9 with respect to x is 0 because the derivative of any constant is 0. Now, at the point 1, 2, we have that 2 times 1 plus 4 times 2 times y prime is equal to 0. So if we plug in the x and the y into this equation, we could solve for y prime, and we get 2 plus 8y prime equals 0. If we subtract 2 from both sides, we're going to get 8y prime is equal to -2. And then when we divide both sides by 8, we see that y prime is equal to -1/4. -1/4. Okay? So there's our y prime. There's our slope. Let me do that. Let me actually write slope. Okay, that's the slope of the tangent. All right, and if we, again, that's what we needed up there, so let's write that in, -1/4. So the slope of the tangent is -1/4. Therefore, the equation of the tangent line, which is part A, is y minus y1. Let me do that in purple. Y minus y1, and y1 is 2, equals the slope, which is -1/4, multiplied by x minus x1, and x1 is 1. So that right there is the equation of the tangent line, and the cool thing about finding the equation of the tangent and the normal is that you just have to change the slopes. That's it. The point doesn't change, the slopes change. If the slope of the tangent is -1/4, then the slope of the normal would be -1/4, flip it over and change the sign. So 4/1 multiplied by x minus 1. All right, let's see if we can finish these types of problems up here within this video. Again, we see that y is not explicitly defined in terms of x, so we're going to take the derivative of both sides. Okay, the derivative of x with respect to x, we know that that's 1. The derivative, why did I put equals? 1 plus the derivative of xy to the 1/2 power. So let's do that. Let me rewrite it like that. That way I don't have to think and remember too much in my head here. So it's easier for me to see it when I see it like this. So the derivative of something to the 1/2 power is 1/2 times that something to the -1/2 power, but then we have to multiply by the derivative of that something. Okay, so just do this step by step. Okay, don't try to do too much in your head. I find that some students get into a lot of trouble. Sorry, I'm talking and doing this at the same time. They get in a lot of trouble when they try to do too much in their heads. If you try to find this derivative, this whole thing, all in one step, you're just setting yourself up for problems. Okay. Notice here, I'm just going to take this part here. Let's do it in red or green. I'm going to take this part of the term here and I'm just going to rewrite it. I see I have a 2 in the denominator down there, and then I also have a radical xy. Okay, so that cleans up that negative exponent. But then I still have to contend with this derivative of xy. And the derivative of xy, we've done this a million times, so I'm hoping that you've got this down. It's the derivative of a product, which means that we have to take the derivative, or the first term, first factor, multiplied by the derivative of the second. So first times the derivative of the second, plus the second times the derivative of the first. And again, all of that is equal to 0. Well, going back up here to the original, to where the problem started, we're already given an x1, y1, and we need a slope. We need a slope at that point, okay? And so we can start substituting in for the x and the y, the 4 and the 1, and see what we get here. We've got 1 plus 1 over 2 times, again, x is 4, y is 1. Okay, so everywhere I see an x, I'm going to put a 4. I can't substitute anything for the y prime because, well, that's what we're trying to figure out. That's what we're trying to solve for. But the y, however, when x is 4, is 1. Okay, so this is a pretty easy equation to solve for pre-calc honors students. Let's just take it step by step, though. This guy right down here, this radical 4 times 1 is radical 4, which is 2. Okay, so if that's 2, and I take my other 2 and multiply it by that 2, then we get 2 times 2 down there is 4. Okay, well, let's see what else we have here. We have 4 times y prime plus 1. Okay, so we have 4y prime plus 1, and all of that is equal to 0. Well, a few different things we can do here. What I would prefer to do is just to subtract 1 from both sides. That gives me a 1/4 times this 4y prime plus 1 equals negative 1. At this point, I could just multiply both sides by the 4. Okay, so I'm freeing up this 4y prime plus 1. 4y prime plus 1 is equal to negative 4. Okay, so let's go. Oh, we got that whole big section right there. So let's go all the way back up here, and we have. Let's do this first. If we subtract 1 from both sides, and I'll put the solution to that up on top, we have 4y prime equals negative 5. Okay, 4y prime equals negative 5. I have this feeling that I've made a mistake somewhere along the way. Normally it doesn't work out to be a fraction like this, ugly fraction, but nevertheless I'm going to go with it, and then I'll check it out later. 5/4 is our slope, so therefore the equation of the tangent line is y minus 1, so this is part A. Okay, y minus 1 is equal to the slope of the tangent line, 5/4 multiplied by x minus 4. Okay, so we have the point 41, we have the slope of the tangent line right there. Slope of tangent line is 5/4, and so that's our equation of the tangent line, and I've got 45 seconds to write down the equation of the normal line. In the equation of the normal line, we have the same x1, y1, but the slope of the tangent line, we flip the fraction over and we change its sign, so the slope of the normal line is negative 4/5, and we multiply that by x minus 4. So there we go. That's the equation of the normal line. Good. Under 15 minutes again.